third stage, and sixth vertex. Are you clear my point? From these two options, you have to select only one. Minimum of from this. Okay, are you clear this point? Then once again I'll tell you. I'll tell you one more thing. Uh, is it? Okay, eraser is nah, the option is not there. Okay, anyway, then come to this. I want to calculate this one. For example, this one. 2 is over. I'm going to calculate 2. That is second stage, third vertex. Now, once you see, listen carefully. Cost of second stage, third vertex. This I require. That means what? From 3, 2 ways are there. One is 3 to 4 is there, and 3 to 6 is there. That's why from these 2 ways you have to calculate minimum one. Minimum of 2 ways are there. What is the first way? 3 to 5. That means C of that edge 3 to 5 plus then cost up to 5. Cost up to 5 in the sense cost of third edge and fifth vertex. Are you clear? This is one option. And second option is 3 to 6 is there. That's why cost of 3 to 6 of that particular edge plus cost of that particular vertex, that is third stage and sixth vertex. Like this, I'm going to calculate. For example, if I want to calculate, if I want to calculate the distance, the cost at this one, let us say cost of first vertex, first stage, first vertex. Let us take. It is nothing but how many ways are there from this? 3 ways are there. 1 to 2 is there, 1 to 3 is there, 1 to 4 is there. That's why minimum of from this first one, way. First way is C of 1 to 2 plus cost up to 2. Cost up to 2. Cost up to 2 in the sense 2 vertex and 2 stage. And cost of 1 to 3 edge plus cost up to 3. Cost up to 3 in the sense second stage, third vertex. Okay. Cost of 1 to 4 plus cost of up to 4. That means second stage and fourth vertex. Okay. From these 3 options, you have to select one. From these 3 options, you have to select one. That is its value. Now, once you see here, cost of 1, 1. This you know that is nothing but 10. This you know that is nothing but 5. This you know that is nothing but 6. Okay. These are nothing but the edges costs. Okay. This is cost up to this. That's why this is recursive function. This is recursive function. This is recursive function. The same function like this. This you calculated already. This is nothing but cost of 2. Where I calculated this one. This whatever value you got it, this you have to substitute here. Okay. Then I calculated 2, 3 also. This also I calculated. That is nothing but this one. Okay. This value you have to substitute here. Okay. Like that you have to calculate 2, 4 also. You have to substitute this. By this what happens? This you know about it. This value calculated, you substitute all these values. From these 3 options, you have to select the minimum one. That is nothing but cost of 1 to 1. 1 to 1 in the sense of first stage, first vertex. That is nothing but what? From destination to this first vertex is nothing but COST cost. COST cost is different. Small c is different. Small c represents the cost of that particular edge. COST cost is nothing but the cost from the destination to that particular vertex. Okay, are you clear? This is a logic I'm going to apply in your in forward approach. Are you clear this point? Then I'm going to see that um, this I can write the one formula. I'll show this formula also. Okay. Let us take this is these are the vertices. Let us take these are the vertices, and this is vertex. Let us take this is okay. This is one vertex. Now this I'm taking as S. This I'm taking as T. Okay, my I is nothing but stage one. This is one stage, two stage, three stage, four stage. My J is nothing but represents the vertices. Okay, J is belongs to vertices, and I is nothing but stages, and S is starting symbol, starting vertex, that is nothing but source, and T is nothing but sink, that is nothing but destination. Okay, now I want to calculate what I'm doing here. If I want to calculate the distance, the cost at this point, that means cost of I is the stage I, comma. If I want to calculate here, what you can write? Actually, if you want to calculate here, what you can write? You can write 1, comma 1. First stage, first vertex is nothing but the minimum of what? This distance. That means C of this 1, 2, let us say this is 2, 3, 4. C of 1, comma 2 plus cost of 2 stage 2 vertex. Is it? Then C of 1, comma 3 cost of 2 stage 3 vertex. C of 1, comma 3, 1, comma 4 cost of 2 vertex at 4 2 stage 4 vertex. Among these three, you are going to take the minimum. Like that, I'm going to write a formula with this equation. Once you see here, I'm taking I as my stage, J is my vertex. Let us take this is my vertex. If I want to calculate this, it is nothing but minimum of what I have to do. I2, this is J2, let us take this is L. L is equal to this 1, 2, 3, 4 like that. That means what? Cost of C cost of I comma J is nothing but C of J comma L, that is nothing but H is 1 to 2, 1 to 2 H. This is J and this is L. So cost of J comma L plus cost of that particular stage and vertex. Then vertex is L. There is no doubt. What is the stage? Stage is here is I. Here is I plus 1. That's why cost of I plus 1, I plus 1, comma, this is L. Only this. Where JL belongs to E, JL is the edge, and J is belongs to E. Are you clear my point? This is nothing but the forward approach formula. Calculation of forward approach formula. Are you clear this point? Are you clear? Now, if I want to calculate backward approach, simple logic, just you have to change this formulas. Once you see here, B cost is nothing backward approach. Let us say this is F cost we are going to use. F cost we are going to use, but here I'm going to use B cost. B cost is this backward approach cost. It is nothing but cost of I comma j is equal B cost of I comma j is equal. All these are the same value, same minimum of JL is edge belongs to edge and J belongs to vertices. All are same. But here this is reverse. Now here we are going to J to J. We are going to J to L. We are going to J to L. But backward approach, you have to move from L to J. That is C of L. That's all. Then plus cost of here I plus 1. You are moving forward. Here you have to move backward. That means what? I minus 1, comma L. That's all. The formula for forward approaches is formula for backward approaches is. But I'm going to explain one problem on forward approach that you have to solve many problems, 2-3 problems you have to solve by using forward approach and backward approach. Are you clear this? How I'm going to do this? Okay. Now you can say that where we are going to use the optimality principle, sir. You can ask this question. I'll tell you clearly. I'm using optimality principle here. Optimality principle is what is that? For example, this is a cast at I place. This, let us take this cast of 2, 2 is there. That means up to here there is a cast. Up to here this cast is there. This cast, what I'm doing, I'm going to saving into one place. I'm storing it to one place. Now, if I want to calculate this cost, what I'm using here, this edge plus this cost I'm using. This edge plus this cost I'm using. That means what? This is a first stage output. This first stage output, I'm going to use the second stage input. Are you clear at this point? This is nothing but implementation of optimality principle. What is optimality principle? Whatever previous stage result you got it, output you got it, that output you are going to take it as the input for the next stage. Okay. Then the same thing I'm using here. This input I'm going to take for this 1, 2. Are you clear at this point? Okay. Now this is a by using optimality principle, I'm solving multi-stage graph by using dynamic programming. Okay. Now I'll move to the problem. This is a okay. Once you see here, what I explain now, that is there in this. Okay. Now I'm going to explain one problem on this so that you can understand very easily how I'm going to see this dynamic programming on multi-stage graph. Once you see here, what I given this formula is once you check this formula. This formula is formula approach. Cost of I comma j is equal minimum of c comma j comma c of j comma l cost of I plus 1 l. Okay, this we explain now. Okay, this here c, small c is the cost of h. This cost is nothing but the cost from the, this is a destination and this is a source. But in multi-stage graph, this we call as source, this we call as sink. Okay, in our examinations also they may use this term, sink term. Okay, now once you see this backward approach, what I told you, I comma minus 1, I minus 1 and L comma j. That means it is reverse and this is negative. If it is positive, I is equal I plus 1, I plus 1, I plus 1 in the sense is moving forward. But I minus 1 minus 1 in the sense it is moving backward. Okay, this is j comma l, this is l comma j. That's all. That's the difference between forward and backward approach. Okay. Now I'll move to the problem. See, I'm going to explain only one problem. Please you have to do 2-3 problems in your home. I'll very clearly I'll explain this problem in each and every point I'm going to explain. Okay. Now here this is multi-stage graph, you know as well. This is S is a starting point, that is source, and this T is a sink. And then we have, this is first stage, and see, this is second stage, third stage, fourth stage, fifth stage. Okay, 5 stages are there. That means I is where is 1 is less than or equal to 5. That I is nothing but stages. Okay. What are the vertices we have? We have n vertices here, 1 to 12. 12 vertices are there. 1 is starting. One more point also you can remember in your multi-stage graph, the source and terminal should be single vertices. The source and the destination should be single vertices. This also one more condition, but I have not explained earlier. Okay, no, you can remember this. Okay. Now, what my point? I'm going to plan this. Now I'm going to write this. This I will write. what I have to write? I have to calculate. I have to calculate cost of I comma the first vertex. I is equal to what? 1. 1 comma 1. First vertex. First stage, first vertex. Then what is the formula? Minimum of how many edges are there? So the 4 possibilities are there. It's 1 to 2, 1 to 3, 1 to 4, 1 to 5, 1 to 5. That means C of 1 to 2 plus cost of 1 to 2 plus C of 1 to 2 in the sense up to here. Up to here, cost of whatever you have the cost from here that you have to consider. That means cost of second stage, second vertex. Okay. And what is the next option? C of 1 to 3 plus cost of second stage, third vertex. C of 1 to 4 plus cost of second stage, fourth vertex. Okay. And C of 1 to 5 and plus cost of second stage, fifth vertex. From these possibilities, from these 4 possibilities, which gives minimum value, that is nothing but this. This 1 comma 1 in the sense, this is 1 is a first stage, 1 is a first vertex. Okay. This value represents the distance from here to here. Very clear? But C of 1 comma 2, C of 1 comma 2 is what? C of 1 comma 2 is nothing but cost. C is a small c represents the edge cost. That's why 1 to 2 is what? 9. This is 9. Then C of 1 comma 3, this is 7. Then C of 1 comma 4, this is 3. Then C of 1 comma 5, this is 2. Okay. Now what about this? What is this? And what is this? And what is this? What is this? Okay. Now what you are doing here? Again, you have to calculate the same. Cost of, let us say, cost of 2 comma 2. Again, you have to calculate cost of 2 comma 2. What are the options you have? This is 1 way, 2 way, 3 ways are there. Cost of 2 comma 2. It is nothing but again what you have to calculate. You have to calculate this formula. You have to calculate this formula. Minimum of just wait. Just wait. Just wait. Once you see here, once you know the calculation of these, you can easily identify. Once you see here, this I am calculating here. What I calculated, cost of 1 comma 1. It is nothing but minimum of